sign, that really means of. So I want 1/3 of 1/2. So the first thing I'm going to do is get a half. And I'll shade that. So I have a half. And I want 1/3 of that half. So I want 1/3 of the half. And so I'll shade the 1/3 of the 1/2. You can see that I have 1, this one right here, 1 of the 6. So 1/3 times 1/2 is 1/6. Let's try another diagram and see how it relates then to the problem. I have 2/3 of 1/4. So first I need to get a fourth. So 1/4 of the diagram, one of the 4 pieces from the whole, and I want 2/3 of that. So I'm going to break my diagram into thirds, and I want 2/3 of that piece. So I want 2/3 of that piece. So the pieces that result in the answer are these double shaded pieces. There are 2 of how many pieces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 of the 12 pieces. Now from reducing fractions, we know that can also be represented as 1/6. So if you check out what's happening here, there's a little algorithm. Algorithm is just a recipe. I really don't want to draw a diagram every time. But if I look at my fractions and I go straight across and I multiply, 2 times 1 is 2, 3 times 4 is 12. The result for the first one, 1 times 1 is 1, 3 times 2 is 6. So if the algorithm is just a recipe, the recipe is telling me to multiply straight across. So that means I'm going to take the numerator of my first fraction times the numerator of my second. I'm going to take the denominator of my first times the denominator of my second. Following that algorithm, multiplying straight across, 7 times 2 is 14. 8 times 5 is 40. And again, we notice that this fraction reduces. I can take half of 14 and half of 40 and get 7/20. There's one way to reduce before multiplying. If I look in the numerators and I look in the denominators, I see that 2 divides into 8 4 times. And if you notice, 2 times the 1 is 7. 4 times the 5 is 20. That's just a way of simplifying before you do the multiplication. Again, applying the algorithm, numerators, 3 times 1 is 3. Denominators, 4 times 2 is 8. 3/8 would be the result of the diagram when I take 3/4 of 1/2. Now division of fractions is slightly different. We're going to take 3/7. I'm going to rewrite it as divided by 1/2. This divide sign, as you know from previous lectures, will make a divide bar. What we really want in the denominator of a fraction is 1. So I'm going to multiply this by 2/1. And what I do to the denominator, I must be fair and equal and do to the numerator. Looking at the fraction in red, both in the numerator and denominator, this is just equal to 1. I can multiply anything by 1 and get the same value back. It's an identity. Multiplying numerator by 2/1 gives me 6/7. Multiplying the denominator gives me 2/2, which then simplifies into 1, which then results in 6/7. Let's try that one more time, and then we'll see if we can't come up with a recipe or algorithm so we're not doing this every time. I'm going to rewrite my fractions as 1/6 divided by 4/5. I want a 1 in the denominator. I'm going to multiply it by 5/4. Looking at the denominator, I have 20 over 20, which I know simplifies down into a 1, and that's really what I was trying to achieve by putting the 5/4 in the denominator. So to make a 1, I must also put it in the numerator, multiplying straight across. 5 times 1 and 6 times 4 for the denominator gives me 5 over 24. Dividing by 1 gives me 5/24. Now if you look what's happening every time in the numerator, you see your fraction on the left, the 3/7. That never changed. This 3/7 is located here. 1/6 is located first. And if you look at the 1/2, look what's happened every single time. Instead of just dividing, I multiply by not this number, but its reciprocal. Reciprocal is taking a fraction and turning it over. The denominator then becomes the numerator. Numerator becomes the denominator. 4/5, reciprocal, 5/4. So there's a little recipe that happens every time, so we don't have to do all this fraction, complex fraction, and divisions. What happens is you end up multiplying by the reciprocal, and the reciprocal is just the fraction flipped over, and it's not the reciprocal of any fraction, it's the reciprocal of the second fraction. It's the second fraction in the list which I switch. Trying a few additional examples. Here's my second fraction. 4/7. Division turns into multiplication over multiplying by 3 over 2, or 3/2. Multiplying straight across, 12. Multiplying straight across, 14. Reducing by dividing numerator and denominator by 2 is 6/7. If I was to backtrack, notice 2 divides into 2 once, 2 divides into 4 twice. Multiplying straight across, there's my 6. Multiplying straight across, and my 7. Trying the second fraction, 5/8. Multiplying by the reciprocal would be 6/7. Again, it's the reciprocal of the second fraction. Going straight across, 5 times 6 is 30. 8 times 7 is 56. Noticing that they're both even numbers. Dividing each by 2 would give me 15. Dividing 56 by 2 would give me 28. Looking back at the original problem before I multiplied, looks to me like 2 goes into 8 4 times, 2 goes into 6 3 times, 5 times 3 is 15, 4 times 7 is 28. Again, you can bypass the simplification if you reduce first. Either way, you'll end up with the same answer.